Lesson 12.5, the Pythagorean theorem. Guess who came up with the Pythagorean theorem? Anybody want to take a guess? It was a Greek philosopher named... His name was Pythagoras. And he came up with this theorem. What's a theorem, by the way? You guys know what an axiom or a theorem is?
An idea that you apply to stuff like a formula?
It's like a rule. You know, it really is. It's like a rule. The Pythagorean theorem is a rule. It's something that you can apply to something on a regular basis. This is what I mean. The Pythagorean theorem is a formula that you can use when you're dealing with right triangles. It's very simple. Let me explain. If I have a right triangle, first of all, what makes a right triangle? A triangle that has a 90-degree angle in it, right? So if I have a triangle that has a 90-degree angle, how do I know if it has a 90-degree angle? Puts that little box, right? Any triangle that has a 90-degree angle in it is a right triangle. Here's what the Pythagorean theorem does. If you know two of the sides, the length of two of the sides of a right triangle, you could figure out the third side by using the Pythagorean theorem. Okay? If you know the length of two of the sides of a right triangle, you can figure out the length of the third side by using the Pythagorean theorem. Here is the Pythagorean theorem. It's a squared plus b squared equals c squared. Here's the deal. A and b are what are called the legs of the right triangle. The legs of the right triangle are what makes up the 90-degree angle. The legs are what make up the 90-degree angle. The two sides that create the 90-degree angle are the legs. The opposite, the angle, the side that is opposite the 90-degree angle is called the hypotenuse. Everybody say hypotenuse. Again, hypotenuse. It's not hippopotamus, it's hypotenuse. Say it again, everybody, hypotenuse. You get used to that word, hypotenuse. The hypotenuse is the side that is not part of the right angle. Now, here's the deal. When we do this, this is A, this is B, and the hypotenuse is C. Always. I don't care how big the triangle is. This is A and this is B. Why are those two A and B? Why are those two sides A and B? Because they're the legs. What do you mean by they're the legs? What makes them the legs? They make up the right angle. They form the right angle. The two sides of the triangle that make up the right angle are the legs. That's A and B. Did you know that I could have called this one B and this one A? It does not matter. It does not matter. Which of the legs is A and which of the legs is B? The two sides of the triangle that make up the right angle are the legs, A and B. The opposite angle is C, which is also called the hypotenuse. Everybody say hypotenuse.
Hypotenuse.
For real, say hypotenuse.
Hypotenuse.
Thank you. Now, here's how the Pythagorean theorem works. If I gave you a right angle, a right triangle, okay, and I told you that this side here was 3 and this was 4, 3 of whatever, right? 3 inches, 3 miles, 3 whatever. And I don't know what that is. This is where the Pythagorean theorem works. Is that I know 2 of the 3 sides. I know 2 of them. I know the legs. I don't know the hypotenuse. Agreed? That's the x. I don't know it. What you do is you plug this into the Pythagorean theorem and solve it. Watch. Watch. Donovan, watch. A squared plus B squared equals C squared. A squared plus B squared equals C squared. Which one is A? It's either 3 or 4. Pick one. 3. Instead of A squared, we're going to put 3 squared plus 4 squared, right, equals, and instead of C, we're going to put X squared. You see what I've done here? I simply replaced my legs and the hypotenuse with what I have. 3, 4, and X. 3 squared plus 4 squared equals X squared. Now, can I solve some of this? What is 3 squared? 9. What is 4 squared? 16 equals X squared. I'm going to move this up here a little bit, so I'm up here again. So it's 9 plus 16 equals X squared. I'm still going down. What is 9 plus 16? 25 equals X squared. Now here's the deal. This is the part that I haven't taught you yet. Is the variable happy right now? Why not? He's being squared. He hates being squared. Okay? He hates that. Here's what you do to unsquare him. What do you think we do? We just did it last lesson. What do you think we do? What do you think we do? What did we do last lesson? What did we learn about last lesson? Not square. Square root both sides. Here's the deal. If I have m squared, and I wanted to get that to be just m, you square root m squared. In other words, what number times itself is m squared? Think about it. What number times itself is m squared? What does m squared mean? What is m times m? So what number times itself would be m squared? M. Because m times m is m squared. So then the square root of m squared is m. Does that make sense? Okay. So here's where we're at with our problem. We got it down to where this is it. 25 equals x squared. Is the variable happy? No. He's being squared. How do I get rid of being squared? Square root. If I square root this side, then I have to square root the other side. What is the square root of x squared? X. What's the square root of 25? So then, the side of that triangle, the hypotenuse, is 5. Let's show you another one. What if I have this? What if I have a triangle like this? It's different looking, and I have 10 y and 6. Are you watching? Okay, 10y and 6. What is the Pythagorean theorem? What is the Pythagorean theorem? A squared plus b squared equals c squared. You have to memorize that. You'll learn next year and in 8th grade in algebra, there's going to be probably, 30 different formulas you're going to have to just have memorized. This is one of them, the Pythagorean theorem. A squared plus b squared equals c squared. Now that I've done that, which one's the A, which one's the B, and which one's the C? 6 could be A, okay, so 6 could be A. We'll put an A here and circle it. Which one's B? Y. Now, why is Y B? It's the other leg, right? The A and the B are the legs. Makes the right triangle. And then 10 is the C. Let's plug it in. Just plug it in. A squared is 6 squared plus Y squared equals 10 squared. I've simply plugged it in. I haven't done any math yet. I just plugged it into the Pythagorean theorem. Now let's do the math. Line down the equal sign. Is the variable happy? No. First of all, let's start squaring things. 6 squared is 36 plus y squared equals, what's 10 squared? 100. Okay. The variable's not happy. We're supposed to do this in reverse order of operations, which means that, do I worry about him being squared yet? No, that's way up on the list, right? We go from the bottom, adding and subtracting. So I get rid of that 36. How do I get rid of that 36? Minus 36 minus 36. Y squared equals, what's 100 minus 36? 64. Now look, is the variable happy yet? No. He's being squared. How do I get rid of something being squared? Square root, square root. What is the square root of y squared? Y. What is the square root of 64? So then, y, come on. So then y, oh my goodness gracious. Y then up here is 8. Does that make sense? You guys try one. Here we go. You try one. What if I gave you a triangle looks like this? I would like you to tell me what P is. One more time. What's the Pythagorean theorem? A squared plus B squared equals C squared. That's right. So here's the deal. What are A and B? What are they? They're the legs. What are the legs? What are the legs? And just as a general rule, what are the legs? The sides that make up the right angle. What's the side that does not make up the right angle called? What's it called? The hypotenuse. Everybody say hypotenuse. Not hippopotamus. Hypotenuse. Let's plug it in. Which one's A? Which one do you want to make A? B. It doesn't matter. Let's make it 12. It really does not make any difference. 12 squared plus, what's B then? P squared equals 13 squared. Okay. What is 12 squared? What's 12 squared? 13 squared. What is 13 times 13? It's 169. 169. What do I do now? Is the variable happy? No. We need to get rid of things. What do I take care of first? Minus 144 minus 144. That leaves me with P squared equals 25. Is P happy? No, he's being squared. How do I get rid of him being squared? Square root. If I square root that side, I have to square root the other side. What's the square root of P squared? P. What's the square root of 25? 5. How many of you got that? P equals 5. Do you understand what's going on now? Do you understand? Yeah. I'm going to show you something that's a pretty algebra concept. Okay, I'm going to show you a pretty algebra concept. It's this. Pay attention. I'm just going to show it to you. This is not part of your homework. Okay, are you watching? A squared plus B squared equals C squared. Okay, A squared, 5 squared plus 7 squared equals X squared. Do you agree that I've set that up properly? Be paying attention. 25 plus 49 equals X squared. That is 74 equals X squared. Is the variable happy? No, square root, square root. That leaves me with X equals, what is the square root of 74? What is that called? The square root of 74 is irrational, right? So there is no number. Now listen, if I asked you to round that number to the nearest tenth, could you do that? Yes. If I asked you to round to the nearest hundredth, could you do that? Yes. If I asked you to round to the nearest 25, or to the nearest trillionth, could you do that? Yes. But if I was to ever ask you for the exact answer, if I ever asked you for the exact answer, What is the only exact answer? There is an exact answer. There's only one exact answer, and that is this. The answer would be the square root of 74. That's the exact answer. The square root of 74 is the best possible answer. To leave it like that, where x equals the square root of 74. Don't forget, what did we do down here? We did, what is x squared? What is x squared square rooted? X. What is the square root of 74? There's no good answer, right? So you can just leave that. X does equal the square root of 74. And that is the exact answer. If I told you to solve that or tell me, what else could I tell you? I mean, like I said, round to the only thing you can do is say round to the, well, see, then it's not the exact answer. What's the exact answer? Square root of 74. Does that make sense? The problem is that the square root of 74 doesn't do anybody any good. You know what I'm saying? Like all of a sudden you need to kind of know what that's near for you to do anything with it. What do you think it's near? What do you think the square root of 74 is near? In between what number? It could be between 8 or 9, right? Square root of 8 squared is 64. 9 squared is 81. It's going to be somewhere in between 8 and 9. Does that make sense? Make sense? Anyway. Okay, let's take a look here. What else you need to do your homework here? They do ask you to round to the nearest tenth on some of these. I am not going to do that. I am going to give you this. I'm going to give you some on paper right now. On this, you're simply going to write this down. It's not going to be from the book. You're simply going to write this down. Do you understand? Okay. So, number one that you're doing, and you need to draw it for me too. You're going to have to draw these things. That's number one. Number two, I'm only going to give you 4 of these. Yeah, this is your homework. There they are. Write them down. That's your homework.